Something is supposed to be happening to Earth right now. For nearly 3 million years, our planet followed the same remarkable pattern. Whenever northern summers became weak enough, winter snow stopped melting completely. That surviving snow reflected more sunlight, cooled the land even further, and slowly expanded into glaciers that eventually covered entire continents. The cycle repeated again and again, leaving an unmistakable record buried deep within Antarctic ice. By the orbital patterns associated with past glacial beginnings, Earth has reached a similar point once more. Summer sunlight at high northern latitudes has reached levels associated with the beginnings of previous ice ages. If the planet were following its ancient rhythm, the first signs of a new glaciation should already be appearing. Instead, scientists are watching the exact opposite unfold. Greenland is losing ice. Mountain glaciers are retreating. Arctic sea ice continues to shrink. The strange part isn't that the next ice age hasn't arrived. It's that the conditions which once announced its arrival appear to be here already. So why isn't the ice forming? The first assumption was obvious. Perhaps Earth's orbital cycles had been misunderstood. But they hadn't. Multiple measurements confirmed that northern summers really had weakened to the point that, in previous climate cycles, winter snow should have started surviving the melt season. The ancient trigger still appeared to be present. Yet every year that snow disappeared. Somewhere another force was quietly overpowering a mechanism that had governed Earth's climate for millions of years. So researchers put the two signals side by side, Earth's orbit and the atmosphere above it. When they combined orbital changes with atmospheric carbon dioxide levels in detailed climate simulations, a pattern began to emerge. The orbital signal still behaved exactly as expected, but the warmer atmosphere prevented the thin layer of surviving snow from lasting through summer. Without that first layer of permanent snow, the chain reaction toward massive ice sheets could never begin. It seemed like the mystery had finally been solved. But then scientists uncovered something unexpected. What if the next ice age wasn't actually supposed to begin yet? Suddenly, the question was no longer why the ice wasn't forming. It was whether scientists had been asking the wrong question all along. The contradiction forced scientists to look backward, not forward. If Earth's orbital cycles were the true clock behind ice ages, then the past should contain a moment that looked almost identical to today. Somewhere inside the ancient climate record, there should be a natural experiment revealing what happens when the same celestial conditions return. The closest match appeared roughly 775,000 years ago, during a period known as marine isotope stage 19. Earth's orbital position was remarkably similar, and after roughly 12,000 years, glaciers began expanding again. Since our current warm period has lasted about 11,700 years, the comparison suggested something surprising. Without human influence, Earth may have been approaching another glacial transition. But the deeper scientists looked, the less certain the answer became. Another research team separated the individual effects of Earth's orbital cycles and reconstructed past ice age timing in a different way. Their results pointed toward a different conclusion, that our current warm period may still have thousands of years remaining even without modern greenhouse gas emissions. 2 studies, 2 timelines, 1 unresolved question. Was humanity stopping an ice age that was already due to arrive, or changing a climate rhythm that was never about to happen yet? The disagreement about Earth's natural timeline remains important, but both possibilities lead to the same unsettling discovery. The clock was never perfectly precise. Climate systems do not move like a machine counting down to a single moment, but across millions of years, its rhythm was unmistakable. Whether the next ice age was supposed to begin thousands of years ago, or whether it was still thousands of years away, the planet we are creating is no longer following either path. The reason appears in the atmosphere itself. For millions of years, Earth's glacial cycles operated within a narrow range of conditions. Small changes in sunlight could slowly push the planet toward ice, while natural greenhouse gases helped determine whether that push succeeded. But in only a few centuries, human activity increased atmospheric carbon dioxide faster than any natural process preserved in the ice record. Scientists tested what happens next by extending climate models far beyond human timescales. The results suggest that the carbon already released is enough to delay the next glaciation for tens of thousands of years. Under much higher cumulative emission scenarios, that delay could stretch far further. A cycle that once unfolded over geological time has now collided with a civilization that changes the planet in centuries. And suddenly, the original mystery looks different. The question is no longer only when the next ice age will arrive. It is what happens when a civilization becomes a force inside a climate rhythm that once belonged entirely to nature. For most of human history, Earth was something we adapted to. Ice ages arrived and disappeared long before civilizations existed. Oceans rose and fell. Continents froze and thawed. Humanity survived by responding to a planet whose greatest transformations unfolded too slowly for any single generation to witness. But the climate record reveals something unprecedented. A species that appeared only a few 100,000 years ago has become part of a process that has shaped Earth for millions of years. Not by changing the planet's orbit, not by moving continents, but by altering the invisible atmosphere that helps decide whether ice expands or retreats. The next ice age will eventually come. Earth's natural cycles are too powerful to disappear forever. But when that distant transition finally arrives, it will not happen on the same planet that shaped the civilizations of the past. It will happen on a planet carrying the evidence of a species that learned how to influence forces once thought to belong only to nature. The mystery was never simply why the ice age clock stopped. The deeper discovery is that Earth's ancient rhythms are still moving, but now they are moving through a planet that carries our fingerprints.